Hi there, and thank you, O'Reilly, and thank you, Yaz, for hosting this. I'm excited to be here today presenting this to all of you, and thank you for taking time out of your busy days to join me for this webcast. Just from a scheduling perspective, I'll try to keep the talk to around 30 to 40 minutes to leave some time for Q&A and for you to get back to any obligations you have after the call. So diving right in, understanding human motivation in the age of connected machines. So I pulled this talk together because, as the physical world is becoming more connected, designers are playing a critical role in shaping that connected world. And we need more actionable methodologies to approach these large-scale connected design problems. So first, just a few notes about Frog. For those of you who don't know Frog, we're a global product strategy and design firm. We began in the early days, it's our founder up in the top left, Hartmut Esslinger, doing work for companies like Apple and Yamaha. And so we began as a physical product design company. However, there's always been a tight-knit coupling between the technology that goes inside of the product and the product itself. So if we look at some of these early ideas, like some of the first Apple computers or some of the first electronics up in the top right, there's always been this relationship between the technology and then the product design. And so these days, what that means is that we get to work on products like this. So things like connected speakers, electric charging stations for cars, concepts to replace public telephone systems in New York City, and then also software, obviously. So as these products have become more connected, I feel like I can share some of the methodologies that we use at Frog with the broader community to continue to provoke discussion around how we can approach problems, limitations, constraints, opportunities around connected products and connected systems. So first, I want to bring up this idea around not designing objects but predicting emotions. And so there's this myth that we can improve things by adding more sensors, more code, throwing more developers at the product, and that will somehow make the product better. And the problem with this is that we know that through these processes, simply adding more sensors to something, adding more code, or throwing more developers at the problem doesn't necessarily mean that we'll make the product better, or that it'll have better market penetration, or that it'll resonate with our customers in a more meaningful way. And so in reality, humans are actually at the center of the equation. And when we're dealing with humans, we're really dealing with emotional, unpredictable creatures that have habits that may not necessarily align with the predicted expectations of the product managers, or that may try to do things with the products that we may not necessarily know. And so there's a lot of emotion that goes into decision making. Humans are irrational at times. We don't necessarily follow the direct path from point A to point B. In this example, this photo that I pulled, there isn't much logic to the situation, right? There's two photographers each doing something else. One may be doing a light check. There's another person doing another thing. And so, humans that purchase the products, that consume the products, that use these things, we can't necessarily predict what they're going to do. But we can take a structured approach to considering how we may design products that begin to extend into this connected space. And so one of the things that we do at Frog is we use experience strategy. And I do apologize, there's a bit of a delay in the lag between the broadcast system and some of the slides that are coming up in real time, so I'll just try to slow down a little bit. So experience strategy. And so one of the frameworks that we use in experience strategy is thinking about the relationship of the product to the person with the acknowledgement that the person has freedom and that they may move in and out of the product's use over time. And so we acknowledge that there are relationships that can be built, tied to emotion, that unlike traditional product design, which uses use cases and siloed functionality to define key moments, we understand that there's freedom that may deliver multiple touch points across a longer time scale. I'll give you an example of that momentarily. And it's all supported by this foundation of design research. And so understanding how customers perceive the product, what are those touch points that are going to make a meaningful impact, and how do they do that over a time scale. So one of the ways that we've recently done this is in the Magic Band for Disney. And so I titled this section, Not Designing the Actual Product, but Predicting Emotion. And so in this case, right, you can think about the problem here. And the Magic Band, for those of you guys who don't know, is a system where there's an RFID in a bracelet, which enables customers to not have to wait in line at Disney, have to order food, can pay for things, can actually track which characters that you've interacted with, things like that. And so you could think of this as the product design, or you can think of the multitude of touch points that may consist of things like a website, a mobile device, or in this case, we help Disney with the signage and thinking about how we can choreograph, again, that relationship that enables freedom for the user over time, and that helps develop this sense of relationship that the customer has. So we're not so much focused on the actual design of the object. We're thinking about how we can choreograph those relationships that are going to build those emotional connections. So we're not so much designing that band that we looked at in the beginning. What we're choreographing and what we want to get to is the emotional connection, as you see here. And so what we're looking at is the actual moment when the girl has the band on. She's using this in context. She's making an emotional connection with the person at the park. And so we know that this is actually a business driver because if we consistently wanted to build more rides, we knew that Disney could actually build more rides. But if we can look at how we can use these connected systems to choreograph new meaningful experiences, we know that it begins to deliver another kind of value proposition that moves beyond the traditional value proposition of product design. And we know that connected systems have the potential to deliver this, and we know that we can begin to deliver this kind of value using this type of methodology, again, experience strategy, and thinking about how we can choreograph freedom of the user and of the consumer to build relationships over time. So another framework that I want to begin to discuss with you guys today that we see emerging in the connected platforms is the idea of immediate convenience, aggregate benefit, and latent value. And so when we start to think about large-scale industrial connected systems, one of the things that I like to use as an example is EasyPass. And so EasyPass, for those of you who aren't in the Northeast corridor, again, I'm broadcasting today from New York, we use EasyPass in our cars to pay tolls as we go through. And so these have different names depending on what state, what country, but they're beginning to be used all around the country and all across the world. And so again, the basic idea is that you no longer have to wait in a toll line to actually make a payment, but there's a connected system in your car that's tied to both your credit cards and the payment system of the toll plaza, which eases passage for users. And so we know that this provides an immediate convenience for travelers, right? So for me, the personal convenience is that I no longer have to slow my vehicle down. I no longer have to roll down my window. I can just drive through the toll plaza, and it automatically deducts from my credit card systems. We also know that there's aggregated benefits from this type of connected system. And so one of the things that we've been seeing in New York is they're beginning to use this censored data to monitor traffic. So they're taking the E-ZPass readers and they're installing them on traffic poles so that they're actually using the E-ZPass identification system not to take payment as users travel throughout the city, but to anonymously monitor where those tracking devices are going. And what that does is it helps provide detailed traffic information at a broader level. So there's the immediate convenience of being able to pass through the payment system seamlessly. There's the aggregate benefit for the community of being able to have a higher level of precision of traffic information. And then what we learn is that there's also a latent long-term benefit. And the latent long-term benefit in this example is really that in a study done on traffic congestion and infant deaths, they actually realized that through this study that E-ZPass implementation reduced prematurely low birth rates amongst mothers who were living around toll plazas in New Jersey. And so what we know is that when we begin to look at these connected systems, and as these connected systems begin to be more pervasive in our lives, that there's an immediate benefit that provides value for the individual, that when we begin to look at the data on a broader scale, there is a communal benefit or an aggregate benefit, and then there's things that we couldn't necessarily look at in that short window because there are latent benefits that we can only look at when we begin to see the impact of that data on specific slices of the community over time. And so we talk about this framework like this. And so this framework is really meant to address the fact that connected products require a new way of thinking. And so when we think about the immediate, aggregate, and latent framework, we look at the personal, we look at the aggregate community, and we also look at the implications over a long time scale. But there's also another way that we can begin to conceptualize that problem space, and that is looking at data, information, knowledge, and wisdom. And so that we know that there's data coming off of the sensors that can be collected, but it really doesn't become meaningful until we turn that into information, knowledge, and hopefully someday wisdom. And so we really see the more immediate opportunity space as being in the place in the middle, as you're looking at in the slide in front of you, where we've moved beyond data delivery and we've begun to think about how we can take that data and really contextualize it into the user's perspective so that they can begin to move into more of the information space and begin to grasp really more of those long-term effects and really get more value out of sensor reading, whether that's ambient or more of a proactive input approach. So I'm going to come back to this framework. And again, this is another way that we look at and talk about the problem space, because we believe that if you're just delivering data to the individual, they aren't going to be able to find value in it, and they really need to be able to convert that into information. On the right-hand side, delivering the data should be the easy part. Moving that data down the framework here towards information and knowledge is really what we want to do, and that's what becomes hard, and that's where we use design research to begin to find those key value propositions. So another tool that we use to think about how we can provide value in connected systems is really thinking about what I like to call the information behavior lifecycle. And so just to give you another common example, when we look at products that you've all heard of, something like Nest, Nest is the connected thermostat that learns your behaviors and then learns to adjust temperature in your home over time. I was really quite sad that I found out the other day I can't install one in my house just because of my electrical wiring. But regardless, we know that in the example in Nest and with physical connected products or assets, the information starts at the product and is actually relayed to either a remote system or analyzed as a sensor reading as data. And so the first step is really looking at that sensor data. We then begin to apply some sort of analysis or intelligence to that data. And that, again, could be onboard or offboard, depending on the specific situation. But we want to use that data and that analysis to actually affect future behavior. So in the case of Nest, right, it's automatically learning the user's behavior so that they don't have to tune the thermostat. It actually begins to do that for them. Okay, so the information behavior lifecycle is, again, the third framework that I wanted to share with you guys, because it's another way that we can begin to think about, are we just collecting data? Are we analyzing that data? And in connected systems, how are we using that data and analysis to actually affect future behavior, to enhance and add value to the physical product? Or in the case of the industrial internet, we really think about calling those things assets on the ground. And so when we start to think about a problem like electricity, one of our clients at Frog that I've had the benefit of working with over the last few years is GE. And so GE is a large client, a large company. For those of you unfamiliar, they work on large, they have a number of different business units that work on everything from aviation to oil and gas to power generation to healthcare. So when we think about something like electricity, GE plays a large role in not only the creation of electricity and the distribution of that electricity. These are massive problems that affect people all over the world, and we take for granted that it's really easy to simply flick on the light switch, and that there's a lot going on behind the scenes that actually has to be in place to generate the power, to distribute the power, to get it into the building. And it's everywhere. And so when we think about a problem this big, and we think about infrastructure, they're really big dollars that we're talking about. So over the course of 15 years, GE estimates that a 1% fuel savings in aviation could be $30 billion. A 1% fuel savings in something like the power generation space could be closer to $66 billion. And the numbers are just staggering, which makes the opportunity for companies like this moving into this space that much greater. And so I want to take you through an example of a program where we were asked to create a product vision which combines legacy power outage systems into a single product offering for GE. And so when GE approached us, they had acquired a number of different products that did digital distribution of power management over the smart grid. They were really siloed at the time, and they wanted to, again, merge these into a singular product. We, again, knew that there are hard assets on the ground, whether those are transmission stations or actually, online power switches. We knew that we had to think about, not only the user interface to this, but we needed to consider from the user's perspective, how are they actually controlling those hard assets? What are they doing with the connected products in the field? And the reason why this is such an important problem for designers to be involved in and for UX design to take on is because that there's an inflection point in the user interface. So when we begin to think about connected products and how those connected products influence things like operations in these connected systems, we know that if we look at on the left-hand side of the field, where on the left-hand side of the slide where it says local, that's really talking about the field, right? So that there's a person in the field who has these goals, these tasks, these procedures that they're trying to perform. There's the connected hardware, which is relaying data. There's environmental conditions. There's safety regulations. And on the right side, there's the remote, right? There's these remote monitoring stations. So whether we're dealing with an industry like oil and gas, or in this example, power generation and distribution, right? There's some sort of remote operations that is keeping things running. And in their minds, they have the cognitive weight of dealing with historical information, regulatory standards, data, services, potentially collaborating remotely with the people in the field. And the user interface becomes this inflection point because all of that information needs to pass through there. Again, connecting the physical hardware to not only the person on the ground, but to the person in the remote collaboration station. And so thinking about how we're going to approach this problem, at Frog, again, we leverage design research heavily, and I wanted to share with you the research methodology that we used in approaching this problem, which has 5 key areas that we begin to dig in with. The first is stakeholder alignment, the second, product demos, the third, contextual observation, the fourth, understanding the day in the life, again, thinking about more of those multiple time frames or multiple time contexts. Through contextual observation, it's important to get into the field and to talk to people who are on the ground working on the assets, because there is such a tight coupling between people who are working remotely in a remote collaboration environment and the people on the ground doing maintenance on an asset. And we use participatory design very heavily to gain an understanding of the key needs of the users by using design stimuli. And I'll show you a few examples of how we used design stimuli to actually better understand value propositions for the users. Now, I mentioned contextual inquiry. We were able to visit remote monitoring centers to actually see what kinds of things the remote monitoring stations were doing and how they were communicating with field crews. Through this process, we learned that safety is of the utmost importance because there's an extreme amount of regulatory conditions that go into how field crews are monitored and managed. And we're dealing with lives. If the power goes on while a field crew is working in the field, it can be deadly. And so there needs to be an exorbitant amount of information and processes that are in place to make sure that people are safe. But what we're looking at here is an example of some of the conditions that people are working in the remote centers. They have multiple monitors, up to 11 that we saw. They have these big boards that they can actually look at the grid with. And again, those are all mapping back to these physical assets, which are transmitting information back to them in real time. And so I mentioned participatory design earlier. So we use participatory design, in this case, to actually help us model out dashboards. So sitting down with users and having a starter kit of provocations that could be potential product features. So again, thinking about the goal of consolidating multiple platforms into a single product offering, we needed to understand what's valuable from the user's perspective, and so that we could better design to align with user expectations and to know that what we were creating they were going to, in the end, ultimately use. And so on the right-hand side there, you can see an example of a drawing of a dashboard that we asked the user to create. And we don't just go and create a design based on what the user says. We have to look for patterns, right? So after doing a series of these, one of the key things that we started to notice was that this idea of a map being central as a summary so that people could get a quick view of what was going on, as opposed to having to go to look at the diagram of where those remote assets were in the field. And I just wanted to point that out because it comes back later. And so through these complex systems, we know that as these systems become more complex and more connected, simplicity is one of the keys to making things easily understood and easily consumed by users. So I really fall into the camp that we need to be able to create more simplified solutions, because as things become more connected, simplicity is a way for people to quickly understand what's happening with the system and to make sense of it so that they can get done what they need to get done. And so as we began to develop this connected system, the user experience that was controlling these assets in the field, we came up with a UX strategy, and that UX strategy had 4 pillars. One was to magnify awareness and safety, and that's probably the most relevant one in terms of relationships to the connected hardware in the field. 2, standardizing data presentation and visualization, again, thinking about how the information being relayed from the devices was being fed into the systems and how that could be consolidated into singular views. 3rd, alarm management was huge just because they're constantly dealing with many kinds of problems that trip alarms. And so, as the industrial internet grows, one of the things that we've seen in the power generation space, power distribution, is that there is so many alarms happening all the time that there's going to be ways that need to be developed so that it's not just constantly like playing whack-a-mole, that there's meaningful things that are actionable that can actually be done. And again, streamlining workflow and knowledge sharing. Again, because this is a 24-hour cycle, we know that the crews coming into the centers need to be able to share knowledge in a more fluid way so that they can have better collaboration on that 24-hour cycle. And so what we began to develop was a new interaction paradigm. And so in the existing systems, what we observed was really an application launcher model, which, for example, if somebody wanted to dive into an asset view of the field and look at their assets that were connected out in the field, they would actually use an app launcher to pull up a network schematic so that they could go investigate further. And so in this consolidation, we wanted to move from, on the edge case 11 monitor footprint down to a more manageable 3 monitor solution. So we proposed this idea of putting together a dashboard that would have a centralized diagram that would let people view data tables, enter information into forms, and then this idea of work pages, which centralized around the idea that we could take patterns that we observed in how people were monitoring their assets and making changes on those assets and actually bring those into a more consolidated workflow. And I'll show you an example of that momentarily. And on the very outset, we began to look at high-level patterns for what that might look like. So again, dashboard being consolidated views and aggregating that information into one consolidated place. The diagram being a place where they could actually look at the hard assets, get information that was being transmitted back. Data tables being a place where they could look at a more tabular view. Forms being a place where they could take action. And then work pages, again, looking at patterns of how people were monitoring the hard assets in the field and thinking about how we could actually build product features in around what we observed. And so one of the things that I want to bring up is this idea of multiple windows. And so when I mentioned that app launcher pattern earlier, it looked something like this. It should pop up on your screen shortly. But what we saw was, all of these windows constantly being open, which really had no rhyme or reason to them. And this is actually a common pattern, is that users would have redundant toolbars. They would have multiple windows open so that they're looking at the hard assets in the field. On the left-hand side, they're doing some sort of manipulation, taking action on the right-hand side. And we saw this as a repeated pattern, and we understood that users wanted to actually take action in a specific way. And so through this process, we began to create dashboards that looked something more like this. So with alarms and management on the left-hand side, again, that idea of that map coming back into play that we saw as this repeated pattern, and then giving them open channels for communications, this idea of widgets that could be customized in the center. And so thinking about how they were doing a task like scheduling crews, again, we saw this pattern of managing multiple windows to both take action on connected assets, but then actually look at where the crews are, schedule those crews during the day. We know that they were using multiple windows to do that. We consolidated that into one work page, or a product feature that we called a work page, that took that idea that they could monitor assets in the top right, get detailed information, and then actually schedule crews in the bottom. When we were beginning to look at the unified product offering, we were able to get this down to a 3-monitor system. And so again, thinking about that dashboard on the left-hand side, in the center column became the primary place where users would interact with the hard assets. So they could look at the network switches, they could look at what was going on with the network in real time, and then on the right-hand side, what they were able to do was be more proactive in terms of doing tasks like scheduling crews and things like that. As we began to pull this together, we knew that there was more heuristic evaluation that needed to take place, so we began to actually set the monitors up into a staging environment so that we could more readily observe things like mouse travel time from left to right, so that we could begin to position key functionality in proximity to each other. We could begin to facilitate the next rounds of user testing and things like this. And so through this process, we talked to users in the field, and one of the quotes that I found particularly relevant is actually from our VP of Innovation Strategy over at Frog. He likes to say, "Sensing is universal, but making sense is highly personal." And here that really resonates because if you think about the sensors and the connected infrastructure, as with the case with EasyPass that I gave earlier, or with the case with this Power On Advantage tool that helps manage digital energy solutions, the sensors and the connected infrastructure are really consistent no matter where they're being placed and what kind of data is coming off of them. But if we think about that data lifecycle that I mentioned earlier, right, we need ways to make the information more valuable so that it becomes this highly personal connection so that the users can find value and meaning in that data. So thinking about problems like this, I want to iterate that there's 3 things that you can do right now when you're thinking about connected products and solving problems of connected products to resonate with customers. One, you can begin to identify meaningful opportunities in the products that you create that move beyond simple data delivery. And so thinking about the connected product opportunity framework that we talked about earlier, understanding that products which are connected can provide more value, need to go beyond just data delivery. Right? If we're just delivering data, it's really not going to resonate, and we need to look for ways that we can turn that into information and knowledge. We can also begin to think about how we can use that immediate, aggregate, and latent framework to think about not just how we can provide meaningful information to singular customers, but also how we can provide greater value to communities and what that means over time. The second thing that we can do right away is we can think about the information behavior lifecycle. So thinking about that connected product or asset, whether that's a consumer product or a large-scale industrial product, we need to think about how that data coming off of that product can have analysis and intelligence applied that will then affect future behavior, which will then add more value to the product and ultimately resonate deeper with users. So making that connectivity work harder for your customers in that information behavior lifecycle is another way that we can look to use connectivity to add value to the products that we create. And finally, considering context. And so as we've worked on a number of products, both in the industrial internet and the connected product space, one of the things that we've realized is that understanding context is really key. So as the locations of use become more obscure in this connected universe, we know that understanding this is really key to making sure that the product can actually be used successfully and that it will really resonate with the end users. And here what you're looking at is a piece of inspection technology being used on the side of an offshore oil platform. And you can see all the immediate constraints. And this is actually a product that we've done a little bit of work on. This was the product before I went through the redesign. But you can see some of the constraints, right? He's actually hanging on the side of an oil platform. He's using his right-hand side to do the inspection. He's using his left hand to actually do input. He has all kinds of safety gear on. And the next generation of this product is going to be a connected product. And so thinking about this context of use is really key to making sure that they're delivering the promise that they have. And so in closing, what I want to impart to you is that UX design and understanding human motivation is really important to companies now more than ever, because getting the data off of the device is often the easy part. But understanding the human at the center of that equation is often the most difficult part to finding value and delivering value for the connected products that we create. And so with that, I'd like to thank you for joining the call, and then we'll open it up to any questions that